Okay, hello, I'm going to start, so if you are still outside and you want to attend the talk, so please go inside and let's just begin. So, Doctrine, you are doing it wrong. It's an obvious clickbait, and when I shared with my family that I'm going to do a talk on a conference, they told me, yeah, but the title is wrong. You cannot tell the people that they are doing something wrong. You need to respect your audience. They don't get it. So what I'm going to talk about is about those small things that they are basically okay. We do it all the time, but there is a better way to do it. And sometimes we just copy and paste from the documentation and it works and it's okay, but we can do better. So one of the first questions I would like to ask is if anyone here didn't use Doctrine or doesn't know what it is. Okay, that was an obvious answer because we are on the PHP conference, so I believe everyone at least heard about it. So let's skip this slide. I don't need to explain it. My name is Suro. I'm working in the Gliwice software house. We are doing a project after project, and it takes like a few months. Quite often, those are legacy projects that we take over after other companies. So I see a lot of code, and in this code, we have a lot of things that can be done better, and I'm going to show you a few examples of things that can be improved when working with Doctrine. I'm coming from the Symfony environment, so most of the examples will be in the Symfony context. The talk is divided into three parts. First, we will talk about the entities. The entity is an object that describes a model in the real world that has its identity. So we can tell that this object is the same only if we use the same identification. And in Symfony, we start with creating Doctrine using some automated tool. It was the Doctrine generator some time ago. Now we have this Symfony maker, and it creates a class for us with all the annotation describing metadata for Doctrine mapping on the database. Those properties have getters and setters, and then we add some relations. Okay, I forget to mention that for the 15 years I was doing a laboratory software, so these examples are in the medical field. So let's talk about medical test order. That's our example entity. So we have a nurse that takes our blood and it's going through various machines and we get the morphology result, for example. So when we're talking about the medical test order, it's nice to have information about the patient. So we have a relation, and the other thing is the list of the tests that are being performed in our blood. What I want to talk now is the thing that we use with every entity is the identity of the entity. This is a tongue twister in English. So ID, according to the documentation and every example in the Stack Overflow and everywhere, it's just simple auto increment. We have been using it for like I believe even longer that I'm dealing with coding. So it's old and everybody did something with it, but it's not the best solution because the entity should describe a reality object and it should be always valid. It is much easier to work with the entity if it is consistent and valid all the time. An auto-incremented ID is not available in the entity until we flash, until we save it in the database, because the database is providing us with those integers. So until we flash, we have an entity without ID. So we cannot do anything with it. We cannot put it on the message queue or something like this. So what we do quite often, we just flash. And we have an ID, and then we do something else, and another entity is being created, and then we flash again. And during our request live, we have like 10 flashes, and this is quite often the case in the software I see. Of course, as I mentioned, having no ID set means that entity is not valid. The ID is not the best thing to use for URLs. Story from over 10 years ago, I was working in the lab and our competition introduced the web service for the results, medical results. One of our colleagues went there to take the blood for morphology. He got a password and the username, and we were playing with the thing they created. After logging, we've seen the list of his orders, and the one with morphology, we were able to click and see result. The file was result.php, ID equals 700, for example. I don't remember the ID. So what we did, we tried 701. It wasn't working. But then there was a button, download the PDF. Again, the URL was result pdf.php, ID equals 700. We tried 701, and it downloaded the PDF with the result of completely different person. What did we do? A loop in a Unix with the wget fetching all those data to our disk. It was running for almost a week. After the week, we have over 500,000 of sensitive medical data on our disk, and we burned it on the CD, and we sent it to the owner of the competition laboratory. So I believe that the developers were screwed. I hope that nobody from that company is here now. It was over 10 years ago, but okay, so this was the story with the URLs. Since then, I don't ever put, I would not put an ID which is an auto increment in the URL. We have some frameworks that will prevent some security, do some security stuff for us, but always there can be some flaw, and you can just leak your data, and it's so easily accessible because the no ordinary integer loop is enough. We use, when you have the auto incremented ID, we sort. But there are so much better things to sort, like creating date or something completely different. So don't sort with the ID. And the last thing is that our code will not work without database. Because if there is no database, we will never have the ID, because we don't have the service that will save it and provide the ID. So let's talk about alternatives. If we don't want to wait for external service to provide us with ID, we need to create one ourselves. The problem is that we cannot, we need to maintain uniqueness of the IDs, and since requests can go in the parallel, integer is not a good solution. So the alternative is quite obvious for probably most of you, and this is the alternative. But it's 36 characters long, and MySQL doesn't have a support for it. So probably you don't need this big ID in the database for every entity you have. Sometimes you have like 1,000 products in the shop, and there will be never more than 10,000. Why do have a UID that takes 36 characters? Another thing is I had the performance issue with MySQL once, and I was doing some research, and it turns out that every index that is not a primary key will use the primary key as a part of it on the data on the disk drive. So if you have a lot of indexes, it will take a lot of disk space, and as a result, a lot of memory if it's being loaded to the memory. So the way to fix the performance issues, either there are two solutions that I came out with then, is to use the auto increment, but do it only for the database sake, and just ignore it in the code and use the UID, which is another column with the index on it. And the other solution is, okay, so sorry, I was talking too much that I forgot to change the slide. So when you have the UID created, you can do it in the constructor, for example, and you don't wait for the database to provide you with one. And if you don't want to play with auto increments anymore, you can, and you don't need the full UID, you can do your own personal unique identification number. And let's start with a unique ID, which is provided in PHP. it itself is a good candidate for it. But I did some MD5 and base 64 encoding and substring because I want only 6 bytes for it, 6 characters, and I translate some base 64 characters that it is URL friendly. I will end up with IDs that looks like this. Those are quite unique. You cannot guess one having the you are not able to guess another IDs having one as an example, so the attacks are not possible as with auto increments. And those 6 characters will give us 70 billion of combinations, so it's more than enough. For most of our needs, 4 or 3 characters is enough. And this is not that uncommon to use so these kind of IDs, because YouTube is using something very similar. You've seen these links. Those are 11 characters which are generated probably in a very similar way. They use it and it's working quite good. So this link actually is a movie about the creation of the IDs by YouTube. So if you are interested, just go there. It's very nice, fast-paced information how they do it and why they do it this way. Okay, so we talk about the ID. Let's move on. We have this entity. This entity has setters and getters. So basically, we end up with something like this. We have an associative array, which is dangerously similar to our class. We can change the state at any time, as with the array. The only thing we have that array doesn't give us is that we have the IDE to help us type. But actually, this data structure doesn't introduce anything new. And what we want is objects have behaviors. So we want, instead of get and set, so there is no behavior. We can do whatever we want at any time. Instead of this, we want to do something like this. For the medical order, patient, barcode used on the tube, and the time that blood was collected will never change. So we put it on the constructor and we never ever have a setter. And then the methods will describe not that I want to set something, but I want to register a new result. So it's business language used in our code, and it describes what we want to do. So we change something that behaves exactly like arrays into proper objects. So they have state, they have validity, and they have behavior described with the methods that mimic the real world. So I think this is better. We fixed something by doing these changes, but the forms doesn't work anymore. And in the documentation, the forms works very naturally with the entities created for the doctrine the way they do, and they don't work with ours, so probably we screwed something up. And no worries, this is not the case. We will leave this entity like this, and we use DTOs instead. DTOs are data transfer objects, so this is simple object that serves only one purpose, to store the data that comes from outside, and we do validation on it, and as soon as it's valid, we can transfer this data into our entity. And we can do it in various ways. One of the simplest one is a factory method, static factory method, and we just create our order entity from the data that has been already validated. So this is a valid data, and we create our entity, and we can work with forms that way. So let's move on to the next part. Let's talk about the relations. Avoid bidirectional relations. This is very often mistake that we just copy and paste from documentation, and we end up with code that is completely valid and very expensive for the processor and for the PHP to do, and we don't need it at all. Let's take an example. We have this medical test order. It has patient. Okay, it's the many-to-one relation. It's completely fine, but on the other hand, we have the class patient that has the other side of the relation, medical test order. This is the bidirectional relation that we don't need. Why we don't need it? Because we are working with orders. We will fetch the order from database and we will display the patient data with it. So it's the bottom part is completely okay. But having the patient to get all the orders, okay, probably you can do it, but there's a better way to do it. If you have a web page, when you describe the history of the medical record of a patient, use a repository of medical orders instead. So instead of for every time build those bidirectional relations, of course, those are only the proxies, but even though they are much more expensive to create than the one-side relation. Another thing that we forget to do is when we are talking about the relation that's always being used. Like, for example, when you're working with an order, the patient will always be described somewhere, so you will get the properties from patient. If you do it eagerly. So if you do it eagerly, you will get those data immediately at the same time with the record, and not in the tweak template, for example, when you need to display some data from patient, then Doctrine will be forced to do another SQL call, and if that's, for example, a collection, or it's just not necessary. We can do it eagerly if we need to. And another thing is that we were taught in the university about the first normal form and the second normal form and stuff, and we want to turn everything into relation, and it's not always necessary. Let's take a look, for example, at the patient that have address. The natural thing is to create the relation one-to-one. Patient has an address. Address has its own table, and we will join. Everything is fine. But for address, it is much more easy to have it as a value object, because it doesn't have a real identity. It's just an address. It can be shared between a few people. It can change, and it can be, just a value object. And value objects with Doctrine are very nicely covered with embeddables. So you create an object that has no ID, and you embed this object in a entity, in a Doctrine entity. That way, this being translated into in this example, 3 fields that are added to the patient object, to the patient table. But when we get this data from the database, we will have these 3 fields turned into the object within the patient. So from the code perspective, it works exactly like the relation, because we get the object inside, but we don't create a special table for it, and we don't join. Another thing is, and that's how it's described in the patient class when you put the metadata on the annotation. But embeddable is not a golden hammer. Sometimes you want to do something more complex, and embeddables only gives you the way to create object that consist of simple types. So there can be only strings, integers, dates, and booleans, and you cannot do a relation there. In one of my last projects, I had a request from the client that he would like to introduce to his payments, to his invoicing system, a possibility to add the comments to the invoice. He wanted that his employees, users of the software, would just add a comment that I called the client for the payment, they will be late, but they will pay in the next week, something like this. So the natural way, the first idea is to make a invoice comment relation, one-to-many. One invoice has many comments. Again, we can join. But after having a conversation with client, I've learned that this will be displayed only with an invoice. We will never make any statistics on it. We will never search for the comments. It will be always as the internal part of the invoice. So we can do We can solve this with the custom type. Doctrine gives us the possibility to define custom type. And since JSON is the type that can hold anything we want, we can extend from it and just have a type to store those comments as a JSON field inside the invoice table. In order for it to work, we only need to implement two methods. The first method is convert to database value. So we will just iterate over these comment value objects and turn them into the table that then being stored as a JSON inside the database. And the other way around is convert to PHP value. We get this JSON, we get the array out of this JSON, and we create those value objects in the custom types. And that way, after we fetch our invoice from the database, we'll have the collection of comments without any joins. Everything is waiting for us. The next thing I would like to talk about are repositories. Repository is a service. This is very important. We have learned to use the dependency injection. It's all over the place, but very often in the controllers we get this get manager, get repository. It's always better to have it injected. It works much faster. It's easier to reason about the code, what is happening in the field. So before Symfony 4, we had to use the factory method in the configuration of services to define those services, those repository services. Now in Symfony 4, we do it this way. We just extend the service entity repository, and it turns those classes into services that can be I missed the word. Auto-wired, exactly. Auto-wired and injected automatically into our controllers or services they need that need those repositories. One of the projects I was working this year had used find all method in the background in the process that was happening during the night to recalculate something and update something. And it was working fine with fixtures, with the staging environment, and with production environment. It was working fine. It stopped working fine after 2 years. It turns out that they introduced so many entities that they wouldn't fit in the memory anymore, and the cron job running the command was just dying, and we didn't know about it. After a few weeks, the client told us that something is not working because those recalculations are not happening, and we were trying to find the solution, the cause, and then the solution. So I think that if we are ever going to do something like this, we can use generators for it. We just fetch the data in the batches, like for 100, 1,000, whatever, and iterate over it. If we are done with those 100, we fetch another 100, and after we are done with the recalculation, we detach it from the entity manager. And this is the safe way to use find all, and you don't care if there is 1 million objects, because if the process is running in the background, it will not run out of memory, it will do its job, and we don't have this issue from the client. Another thing that is very powerful with repositories is that you can do your custom repositories, so you can define queries that are used all over the software, and you can use the business names for it. So instead of making SQL queries, you do it once and you have the method that has a name. For this invoice, for example, we can have in the repository method that is called overdue invoices, and it will check for all the invoices that are due before today and they are not paid. And this is the method that will give us the not paid invoices. But in the software, we are not thinking about what does it mean to have the invoice overdue. We have a method, repository get overdue invoices, done. If the logic will change at some place, we will just change it inside the function, inside the method, and it will work as it worked. But this is very nice to have these queries that reflect the need of the business, of the feature of the client. But then the client talks that, you know, we have these products categories and some of them are luxury. And I would like to have the invoices with luxury products just to display those clients. So we have another method. Then there are VIP clients. There is some logic behind the client being VIP, and we have invoices with VIP clients. We have already 3 methods. It's very easy to use because we will just fetch this kind of invoices or this kind of invoices depending on the feature. But this is the beginning. Then something like this happens. There is new feature request and another one, and we have not pay invoices, overdue invoices with luxury products, not paid invoices with luxury products, and so on and so on. You can imagine that after each feature request, you add another function, and you end up with a repository having 3,000 lines. I've seen these repositories. Even now, I keep seeing it. And in order to introduce some order, the people try to refactor it, and they extract some common parts to the private methods. And having common parts in private methods in the 3,000 liner, it's a hell to debug because you would just jump up and down, and after some time you realize that you don't understand what this method is giving you back. So this is madness. The refactor creates mess. This is the only situation when I've seen somebody try to refactor and end up with a worse code than it was before. Marco Pivetta, on one of his talks, mentioned something he called query functions. After I've seen this talk, I was looking in the internet for it, and I didn't find much. So basically, it's like a 30-second in his talk. That's the all information I found on the internet. But I played with the idea. The idea is that we create the classes. I go back for one. For these methods, we create separate classes. The class can look like this: overdue invoices. Marco and we have encapsulated the method within this class. We inject the repository to have the ability to query the database, and we have encapsulated the method into class. Marco is using invoke magic method here, but I started to inject those query functions, and when I inject it, I needed to do something like this, and it's a personal thing, but I don't like this, so I decided to have it name methods. And the other thing is that maybe I will need the query builder, not the result. I can do the second method here, get the query builder, get the result, and I am a little bit more flexible with it. So this one is blah. How do we use it? We have some service. It works on the overdue invoices, sending some emails to ask the clients to pay it or something like this. So we inject only this query function, not the whole repository. That's the nice thing, because we already know what we are going to use, and not the repository, one of these 100 methods in here. We do something like this, get the result, just a normal thing. And instead of having 20 methods, we have 20 classes. And the very nice side effect of it is that in our IDE in PHP Storm, we have in our project tree list of all the methods, all the queries, all the functions that we had in the repository. We have it listed here. So at the first glance, without scrolling these few thousand lines, we know what has been prepared for us as a developer from the business side, what kind of queries are being executed on the repository. But then, what about don't repeat yourself? Most of these classes have common logic of, for example, finding overdue, because those are overdue with luxury products, overdue of VIP clients and stuff. So we can try to extend, and we will end up with the same mess as with the private functions. So what works very nice is to have another kind of classes which holds the criteria. We hold the criteria here, and we just define the part that is checking for being overdue, and this criteria is being returned from this class. And in our query function, when we get the result, instead of this SQL being built with the expression builder, we just create the criteria class and we add criteria to the query. This way, this is very readable, shorter, and we can reuse the overdue invoices criteria in other classes. I mentioned Marco talk. It has been an inspiration for me. So if you don't know it yet, I strongly recommend this talk. It's one of the, this very great stuff about Doctrine. And that would be all. Thank you. Any questions? Great, I love it. You can find me today after the talk or the whole Saturday if you have any questions. Thank you again.